so this video I'm going to be walking you through how to do Lab 10 Earth History. So Earth history is kind of a funky topic where labs are kind of tricky. It's hard to do a lab activity on the history of the Earth, but I think this is a good lab, and I think it will be really nice to visualize some of the Earth history's events. So one of Earth's most significant tectonic event that happened was this breakup of Pangaea, which happened, formed 335 million years ago, broke apart about 200 million years ago. And this was the breakup of the big supercontinent Pangaea, and this reorganized our continents to the locations and orientations that they are today. So this was our last huge supercontinent reorganization called Pangaea. Okay, so I have this really cool Google Earth layer to work with for part 1, and I will just, show you wherever my Google Chrome is. Okay, here we go. So I have the new KMZ file located. It's called Pangaea Breakup File here, so download that again, and then you're going to open it up into Google Earth, which is, gosh, I'm a little disoriented. Okay, here we go. So this is what the layer looks like. And if it looks like this, it's pretty busy. You see a lot of colors. What the heck is going on? A little tip, turn off your primary layers. That should help things load a little bit easier. This is a big data file, so it might be a little bit slow. Just be patient with it. And then I would go to features and just turn off some of this stuff because it's pretty busy. So I would turn off lithosphere age, a couple of these actually. Paleozoic glaciation, fossils, mountain belts. I would just turn off all of them actually to begin. Okay, so I've turned off all the features. Now if I rotate this around, I see Pangaea. Okay, so I see our last supercontinent, right? And if you're unsure what the continents are, you can turn them on and off to figure out which one is which, but you can pretty much tell based on the shape of the continent. Okay, so for example, I will turn off Africa, turn it back on. Okay, so you can get kind of familiar with the different continents that you have on this Pangaea guide. So one of the first things I would do when playing with this is to go down to the tours and play them and see what they look like. So really cool thing, I'm just going to double click. I'm going to center on North America. Then it plays a little movie video showing what's happening during the breakup of Pangaea, just focused on North America. Okay, so you can see things are shifting, moving around, reorienting themselves, forming the continent that we know today. If you ever want to stop it and play it at a certain point, there's a slider bar here where you can put it pretty much anywhere you want, or you can replay it from the beginning and just observe what you're noticing here. So I would do that with a couple of them. So I'll do it again with, let's do the Indian Ocean. That's a fun one. So this is India down here, this green, and you can watch what happens to it. Just kind of shoo, zips right up there. And now we have our Himalayan mountains. So play with these tours. And again, I would turn off the features just because it's pretty busy if you have all of the features on when you're looking at these tours. It's nice just to have the continents on so you can see the different reorganization of the continents just the way it is. Okay, so that is this Pangaea KML. Okay, you can also just flip these on, and I would probably do them just one by one, just so it doesn't get too busy. Okay, so I just turned on fossil distribution. Okay, so you can see the different fossils that they used as evidence of this continental drift. in this continent reorganization, you can click this drop down so you can see what types of fossils they used. So this Glossopteris fossil, which are these fern-like fossils, you can turn them on and off, again, just to see what kind of symbols are for each. Mesosaurus are these kind of, whoops, there we go, marine creatures. Okay, so you can play with that. Again, look at the drop downs. Turn that off. And same thing with all the other features. So you can turn on the mountain belts. Okay, to see how this looks. And again, they should have, let's see, they should have names to them all. So different types of mountain belts. So again, explore the drop downs, turn off each layer. And that's pretty much it. So you're really just turning layers on and off and making observations. So there are a couple questions, and I walk through basically all of what I'm saying now here in the Word document. But it just asks a couple questions. So there's about 8 questions, multiple choice based on this exercise. Okay, and that's part 1. So that should be pretty simple. It's mostly play and to be able to visualize what's happening during the breakup of Pangaea. Okay, but I'm going to turn this off and go to part 2 and walk you through that. So turn off. Okay, you can just exit out of that. Okay, so part 2 is this idea of linking Earth's history to Earth's present. Okay, so the present is key to the past, right? So we can look at the processes and events that are happening today, and we can link them to the past. Because the same processes are happening today as they did millions and billions of years ago for the most part. So being able to look at something that's presently happening and linking it to our past. So I have this geologic safari for you all to go on using the East African Rift, which is an active continental rift, and linking it to the Hartford-Deerfield Basin. So right here in Springfield, Mass, where we all were once upon a time, and looking at the tectonic forces that pretty much shaped Springfield, Massachusetts, which was an ancient rift zone. So we're looking at an active rift and comparing it to an ancient rift zone. So the first couple questions just ask about rift zone. So what do you know about divergent plate boundaries? What kind of volcanoes would you expect to see? What kind of magma, lava, that kind of stuff. And then the next set of questions, you have to go to a PowerPoint, which I have uploaded. Okay, and it will walk you through just the different types of landforms. The here is the East African Rift outlined here in this dotted line, showing plate motion. Okay, it's telling you what happens at a continental rift zone, that kind of thing. Just go through this slide and answer the questions. So, for example, number 4, look at the maps of the faults that define the East African Rift Valley. A cross-section of the Rift Valley is shown on, that's a typo, on slide 9. What kind of faults do you see? So you can look through this, go to slide 9, and look at the different types of faults that you have in cross-section here in the African Rift Valley. Okay, and figure out what type of faults they are. It's actually labeled for you, so that's cool. This is another picture of the same type of fault, etc. So go through those questions by looking at the PowerPoint. After question 6, you're going to have to turn to Google Earth again. So we're using the 2 KMZ files from last week, so the volcanoes and the USGS 5.4 earthquakes. So I'm going to go to the East African Rift. I'm just going to Google Earth and search it. Come on. It's thinking. There we go. Needed a minute to wake up. Okay, so it's going to zoom me in, way in. I don't want to be zoomed in that much. Okay, this place mark is just to put you in the right direction of the East African Rift. And you can actually see it without any other layers turned on. You kind of have this light outline of land here, right? So this is going to be the East African Rift. I'm going to turn off that pin, and I'm going to turn on the 2 layers that I want from last week. So here's my earthquake layer. I want that on, and I want the volcanoes. Okay, I would also turn on the borders and labels layer too, because it has some neat features. So for example, for under borders and labels, I have this East African Rift place mark, and when I hover over it, it highlights the East African Rift for me, so I can see exactly where it is. Then you see all of this nice chain of volcanoes, really highlighting where that rift is happening. Then you see some earthquakes. Okay, so the next set of questions is really just about your observations using these 2 layers. What types of volcanoes are you seeing? What are the distribution and depth of the earthquakes? So are they shallow? Are they deep? And then make a few elevation profiles across in a few different locations. You don't have to include these in here. It's just to see the change in topography and the change in elevation if you were to make an elevation profile right across the valley. So for example, from here to here, right? And the valley is pretty narrow, so you can zoom into, maybe do an elevation profile right across, like so. Okay, just to see the topography change. Okay, and then once you're done with that, you're pretty much done with Google Earth Pro. So some of you might be happy with that. Some might be sad. And then you're going to go back to the PowerPoint. Okay, so now we've looked at the East African Rift through cross-section, geologic maps. We looked at it in Google Earth. Now we're going to look at the ancient rift, which is in Springfield, Mass, in the Hartford Deerfield Basin. Okay, so there's a Google Earth interlude. Now we're returning back to the PowerPoint. Now we're going to look at an ancient rift system. Okay, so again, there's a set of slides walking you through what the ancient rift looks like in the rock record. Okay, and how we can compare an ancient rift to an active rift. So there's a couple questions about that. Okay, so it'll direct you to the slides. So go to slide 30. What are the similarities? What are the differences? Rock type, faults, that kind of stuff. And then a general question just about your opinions, your feelings about it. And then part 3, I have made extra credit. So I will tell you about that. Dinosaur extinction event. So this is a really cool Google Earth web. Oops, hasn't quite loaded. Let's see. Give it a moment. It's thinking about it. There we go. Okay, the day the dinosaurs died. So this is extra credit. Okay, and this will have a journey into how they figured out that there was this major extinction event and how they figured out how the dinosaurs disappeared. So this is walking you through how scientists use real data, real observations in the rock record, and various other tools into figuring out what caused the disappearance of the dinosaurs and at what point in time on the geologic timescale did that happen. Okay, so this is extra credit. There are some videos that you can watch at each stop, so these are helpful. So play the videos if you want to do that. And if you're interested in doing this extra credit, you can try and figure out where this impact crater occurred on Earth. So one of the big questions that scientists have was they pretty much figured out that there was this big impact crater that wiped out the dinosaurs, but they weren't sure where it was. So they went and looked at the specific clay layer in the rock record that told them that there was an impact event, and they used tools in the rock record to figure out where this impact crater happened, kind of like a hot, cold type of thing, trying to figure out where this impact was. Okay, so where's my Adobe? So here is a PDF with all of the evidence that the scientists use. So there's a series of core logs walking you through different locations on the Earth where they found evidence of this impact crater. And based on the different tools that they used, so tektites, shocked quartz, nickel-rich spinel, etc., they were able to piece together where this impact crater happened. So this exercise uses these real core logs of the rock record to try and figure out where this impact was. So for example, this core log, it has only 2 to 3 millimeters thick of material with this evidence of an impact crater, versus the next core log, which is about 5 millimeters thick of this evidence of an impact crater. So you can imagine that the location of this impact crater probably happened closer to this location than this one. Okay, so that I hope that makes sense to everybody. So if you would like to do that extra credit, you can. If you don't actually want to do the find the impact crater and you just want to go on the voyage, and do that, you can, and then just write a quick summary of what you thought about it and how scientists were able to make this discovery. So that's an option too if you would like to do that instead of actually finding the impact crater, because it is cool and it is fun to see how scientists were able to piece this together. That's the lab. I hope this was helpful, and with that, email me with any questions, and I am signing off. So thanks.